we're still on 13.5, and now let's talk about how to express the acceleration vector in terms of a tangential and a normal component. And what this means then is just that the acceleration vector A can be written as AT times T hat plus AN times N hat, right? Where AT and AN, these guys are scalars, okay? And how do we find AT and AN? Well, the book has formulas for them. So AT is the derivative of the magnitude of the velocity vector. So the same thing as the derivative of the magnitude of r prime of t. And then AN is equal to, well, the curvature times the magnitude of the velocity vector squared. Or if you found AT already, you can use the fact that then this is equal to the acceleration squared, or the magnitude of the acceleration squared minus AT squared. Okay, and so how do we do this then? Well, we want to write, so let's look at 13.5.2, and we want to write A in this form listed above. Okay, so we want to write A in this form right here, and it gives us then R of t is equal to 1 plus 3t, t minus 2, and negative 3t. Okay. Then the next step, well, it looks like we need to find AT, right? We need to take the derivative. So let's take the derivative, then r prime of t, if I can write this right. Okay, so r prime of t, then is going to be 3 comma 1 comma negative 3, right? And what's the magnitude of r prime of t? Well, that's equal to root 3 squared plus 1 squared plus negative 3 squared, which is 9 plus 1 plus 9, which is root 19. And then where are we now? We have root 19. And so what's the derivative of r prime of t? Well, we're taking the derivative of root 19, right, which is a constant. So that derivative is 0. So then this implies that AT is equal to 0. Okay? So that's the tangential vector. The tangential component is going to be 0. And then the next part, what we want to do is find AN. So what's then, since we have r prime of t, right, we then see that r double prime of t, which is the acceleration, right, r double prime of t is equal to, well, the derivative of each one of these guys, the derivative of 3 is 0, the derivative of 1 is 0, and the derivative of negative 3 is also 0. They're all constants, right, which means then that the magnitude of r double prime of t is going to be 0, right, which then is, right, so when we write A, the magnitude of acceleration squared, that's the same thing as this guy. Okay, so this is equal to the magnitude of acceleration is 0, and that means then that AN is equal to the square root of a squared minus AT squared. Well, that's just 0 minus 0. Okay, so AN is also 0. Whoops. AN is also 0, and therefore there's no acceleration, right? So if there's no acceleration, then A is equal to 0 t hat plus 0 n hat, which is simply the 0 vector. All right, and this seems really stupid that we wrote 0 in a really fancy way, but you know, that's just happened with this problem, and I encourage you guys to do it then with 13.5.1. I believe that one's in my notes. If not, I did it in a recitation in one of the semesters. So, quick video, and we have one more talking about the T and B frame. I'll get to what that is in that video, and then we're going to move on, I think, to section 14.2.